Hey, so what we're trying to communicate here is that we are naming our releases. And what that means is every month we're trying to organize our work so you have a better sense of like what we're working on now, what we're working on over the next couple months. And it's kind of coming together. So January was like a little bit of a give. We had a bunch of in-flight stuff. And February is shaping up to be pretty awesome, at least from my perspective. And we were working on to find, it's like the old WordPress names. We're all jazz artists. This is under the bucket of innovators. And while searching around to find cool innovators who were born or did cool stuff in January, we found Mary Elizabeth Anderson, who evidently invented the windshield wiper after a terrible New York City snowstorm, which felt so apropos while we were putting this together. I guess she kept watching the guy in the trolley like reach his hand around and clean off the windshield with his hand. And so she was like, I got a better idea. She ended up not making any money from it, but a very forward-looking lady. So she got the first one of the year. And as we go to slide 4, we're working on this stuff in February, and we're naming it after a guy named John Blankenbaker. Anyone know John from the Computer History Museum? Rob, you got to know John.
No, I don't. I'm looking at the little machine he's got there. It looks
Yeah.
cool, but I know I've
Wi-
never heard of this dude.
Widely
Tell me.
recognized as the inventor of the first personal computer.
Ah,
I mean, he only made like they're not sure if it was 49 or 51 of them, but
but it's actually
it
a
wasn't,
lot.
it wasn't a big seller.
Yeah.
I think it was an early edition. So anyways, that's in spirit
Yeah.
of our Datum Desktop app, which we are releasing. So that'll be fun to talk about and you'll see more. And then there's a bunch of other stuff. So feel free to click up into, we'll put a link in the chat here, but to our milestones, you'll see them shaping up. And, maybe it's an easier way for you to keep track of what we're working on. Okay? Cool. All right, we can move along then. Hey, Zach, I hope you don't mind that I put pictures of your dog. Yeah, is this Mochi?
Yes, that's Mochi, Mochi girl.
Mochi Girl. You're going to have to tell us all about Mochi Girl. But what we wanted to do, because actually a lot of our chatter in Slack and Discord this month was around stuff we're just like learning along the way. So Zach's been doing a lot of learning, I think, over the last couple months, but especially over the last month. So we want to kind of get some previews of that, what you built. You can do some demos or show what you broke. And then we can talk about that and see if there's any questions, and then we'll move along to Scott. Yeah?
Cool.
Cool.
How long do I have?
You got as much time as you want, but probably like 20 minutes. Yeah?
Oh, I should be able to do that. Yeah.
Yeah. Sylvia, you can stop sharing. Let Zach take
Well,
over in case he wants to.
as long as Josh only throws me softball question. But
Easy answers only.
yeah. Cool. So yeah, what have we been working on here? Well, I guess to start, we kicked off kind of the Datum Desktop product. The goal here is that we can allow anyone to connect a local service, think some local app that you have running to the internet, to our public Datum host names. So give somebody a URL, let them hit your local machine and see what you're working on, kind of a deal.
ngrok. Anyone use ngrok, right?
Yes.
This is ngrok. Yeah.
The interesting thing here is that we are taking a bet on a pretty sweet technology called IRO. IRO allows you to dial by key instead of dial by IP. There's a bunch of cool technologies kind of around that, like Quick and that hole punching and other sorts of things. But it becomes super useful in a world where there's a lot of privately connected things that need to talk to each other. And IP might not be consistent over time. And you'd rather just be like, I want to talk to this specific device that's over here, figure out how to connect to it and talk to it as efficiently as possible. So the architecture is really a couple of different components. So Envoy, which I think a lot of us here are aware of, is kind of our public ingress. There's what we call the IRO gateway, which is responsible for actually dialing that specific device by its public key ID. And then there's the IRO relays, which are basically pretty just dumb like relay nodes that can help facilitate traffic when there's no direct peer-to-peer connection. So part of what IRO does is during kind of its loop, it will see if it can actually establish a direct tunnel to that local machine. If it can't, both the desktop or device and the client will kind of meet in the middle at an IRO relay, and the relay will help facilitate that connection. So you can think of a scenario like, I'm hosting something through my public endpoint, and I want to give it to somebody in Australia. Well, Datum's 17 pop locations and growing all do Anycast. So like, how would that work, right? Well, the person in Australia would hit something or hit one of our pops that's closest to them, and it would say, "Hey, I'm trying to reach this, public endpoint that Zach gave me, which is connected to my local machine here in San Francisco." Um, the way that it could dial that connection is it could just go directly from our POP in Australia to my machine if the internet was so kind to provide a perfect traffic highway directly to my device.
Super
That's
sweet,
not
man.
that's not
That'd be
always the
great.
case, right? And so what that would mean is that my local machine, when it turns on and it tries to advertise itself, it would find the closest region or relay to itself. And so in this case, it would find something, I think, in SJC, and it would say, "Hey, I'm here. Here's some of my IPs, and here's also the closest relay to me." So that when the person in Australia tries to hit my device, it might actually go to that relay first and then down to my desktop machine, potentially even establishing a direct connect tunnel along the way. So yes, lots of complexity here in terms of like, our Anycast architecture, our relays. There's also a piece on discovery. So one thing that's really cool about the IRO protocol is that you have a couple different discovery options. And so one of those is DNS. So, the common model here would be like, TXT record gets published for a specific device, and it holds some of that connection information. What's the closest relay to this device? What's some of their public IPs and ports that are open along that, internet journey? And that helps, of course, just a lot of different things. Advertising yourself, saying, "Hey, I'm here. You can connect to me," and also giving a hint to the IRO gateway to say, "Can I, do I already have this information available where I can just simply dial instead of having to like figure out where that user is or that desktop is?"
Right.
So those are all the different components at play here.
Which you can now see why we started with this thing called Datum Desktop, which is really an excuse. We're not trying to be in the expose local services to the internet business, although bringing new stuff onto the network is cool. It's really to show how we can stitch this all together. And I think that's kind of what's cool about the way you're talking about it now, Zach, versus 6 weeks ago, is with a sense of like how all this stuff can and will work and stitch together so that we can extend the concept of, peer-to-peer and IRO relay tunnels to many other places versus from like a controlled client only.
Exactly. I mean, you can think of, a lot of scenarios where like in the cloud, if you're a Kubernetes user, there's a chance that you're connecting nodes from different cloud providers or different VPCs, and you might automatically think Tailscale, WireGuard, et cetera. This is another potential alternative to that, where it's like, "Hey, we want these nodes to be able to communicate to each other privately." When we have our SDK, hopefully in the next, month or so, you'd be able to just simply turn on agents on both sides, and they can, connect to each other efficiently. Built on quick.
Are you going to show it? We want to see
Yeah, I'm
the
going to
quick
show it
buttons,
now.
man.
I'm done talking. But before I show it, I'm going to show you more boring things that just kind of show. So part of like, my learning philosophy is to like break as much things as possible rather than like research a bunch and then like ship something that like may or may not work based on what my understanding was. I like to just like say, "Okay, what's the minimum thing that we want to try to ship here? How can we build it? What are we going to break along the way?" And then continue to iterate from there. So kind of like 2.0 agile in the AI era. Um, Everything's built in Rust here as well. I am new to Rust. So that makes it more challenging as a developer of like, when you're trying to debug things, it's easy when you understand the language. It's not so easy when it's a brand new language that you've never really read before. So, luckily AI is a god at most languages, and you can use it to, decipher what's going on and figure out along the way. Yeah, let me show you a quick demo, and then I'll come back to the boring stuff.
Oh, it's cool, man. I'm actually, but sure, it sounds fine.
Yeah. Okay, so Matt, who's not on this call, has been amazing from a design and UI perspective. He just touched this up, so it looked a little bit different yesterday if you were playing around with that version. but really easy to create new tunnels. So look something like this, right? Give it a name, specify the target and port that you want to expose. Basic authentication is coming soon, so we'll auto-generate you username and passwords to use if you want to protect kind of your tunnel and message your friend and give them the password to use it. I have one currently exposing port 5173, and I have a public datum host name that is available. So that's right here. Just to have some fun while we're on the call here, if anybody wants to join in, you'll be able to connect to my tunnel, which is running my local Python 3JS game server, if you will. And maybe in about 5 seconds, if we all click ready to battle, we can hopefully not blow up my local machine and kick me off the Zoom. Oh, we're in. All right. The goal is to slice and dice your opponents. But yeah, so this is all going through my local machine. I'm not sure if everyone here is co-located in San Francisco, but you can see we're doing pretty well from like a network perspective. Latency is decently low. Um, this is actually doing, I think this is actually doing the WebSockets upgrade. So another cool thing about what we do is that we allow extended connect through our Envoy so that you can, get an end-to-end WebSocket tunnel if you so please. Gosh, who's winning here? Are we done? There's too many people. But yeah, so that's an example of like what this looks like. Back to the boring stuff. There's lots of different HTTP, opinions, RFCs, and protocols. We're trying our best to support as many as possible and the more common ones. So some of the challenges that we ran into early on was like we have a couple of different hops here. We have the first hop, which is directly to, the public ingress. We have the public ingress envoy to IRO gateway, which actually runs as a sidecar. So it's talking to itself mostly in that hop. And then IRO gateway, obviously, to the relay, and then or to the device directly. We are actually deploying our own fleet of relays so that everything will be end-to-end on Datum as well. That should be hopefully getting delivered in the next couple of weeks. But one of the challenges that we saw is like, okay, if we're tying the IRO gateway to Envoy in terms of like literally running it as a sidecar, that means if we push any update to our IRO gateway, it causes our Envoy to actually do a rollout, which isn't ideal, right? Now, of course, it doesn't necessarily mean downtime. We do any cast and they're not all going to be like offline at the same time and we keep one node online. But to decouple that, we actually were able to work with the IRO team to get UDS support into what's called IRO proxy utils. That is kind of their util library for a lot of different functionality. What this allows us to do is now, since we already run Envoy as a daemon set on every node in the cluster, we also will be running IRO gateway as a daemon set in the cluster instead of being inside the container. Both of those will talk to a local Unix host on the node, so that doesn't have to be together. There's no kube proxy DNS hops. So like if you were to do a classic like call this Kubernetes service, you actually go through a lot of like the Kubernetes internals networking stack. So instead of that, we said, no, we want to just like have it be as clean as possible, efficient as possible. Let's have them talk directly to each other over a Unix socket. It doesn't change anything about the protocol that they're using. So it's still a TCP tunnel, still H2C. We went with H2C here, which is, HTTP2, what is it? H2 connect, no, H2 over clear text is what I think the official naming for that is. Basically, the small hop between Envoy and IRO on the local node. We don't need to do things like TLS and add unnecessary overhead there. What we did want is multiplexing so that we can use, a couple of connections and then stream a bunch of different clients on top of that. The IRO gateway already does something similar with Quick, where it has, one quick connection to your device, and then it can stream a bunch of different quick streams on top of that. So So that was kind of the fun first, like big one of like, okay, let's decouple both of these deployments. Let's make sure that the networking between them is still efficient, and not slowing us down or putting us kind of into a wall. Um, yeah, lots of different IRO or Envoy config that we had to figure out how to work with and mix and mangle. The last thing that I was working on last night before I'll hand it over, or just open it up for questions is, we want to be able to make, okay, so yeah, part of our design for this was that, we give you a path like this. If you want to slice and dice your route to actually talk to multiple different backends or tunnels, we want you to be able to do that. With a lot of other services that you've probably used, you get one of these and it talks to one thing. In our case, you can actually do something like, app one and then, app two, and those could be actually two different tunnels. So there's probably interesting scenarios where like a team is working on an app and like maybe like part of the app is hosting the back end, part of it's hosting a database, and part of it's hosting some front end. You could like let it talk to each other over just different paths. Um, Maybe other use cases as well. Maybe that wasn't a good one, but like that's part of the initial design philosophy. And so with that, it becomes interesting, right? Because Envoy typically wants to structure things around the host name, especially when you're doing things like TCP tunnels. And so the moment that you want to actually slice and dice HTTP, but still go down a layer and say, we really want it to be just a normal TCP tunnel, of course, running HTTP on top of it. Envoy's not really built like for that use case. And so we kind of have to massage it a little bit to get it to do what we want it to do. Um, but yeah,
Magic tunnels
yeah,
is the answer. Yeah.
that's a bunch of stuff that I've been working on and trying to figure
Can
out.
can
And
you just riff a little bit more, Zach, before anyone have any questions, but about your relationship with Rust as part of this? Because you mentioned that wasn't a language you were super familiar with, but you kind
yeah,
of knew some Cursor and Cloud friends who were like.
yeah. Yeah, so like the first thing that I think I actually like did that was official was just like this teeny little bug fix in Hickory, with SOA records. Like, typically with replication, the SOA record indicates like the latest timestamp, if you will. It's like a serial number that says, "Hey, this is my update. This is my number. If you don't have this, reach out to me and I'll give you the latest records."
Mhm.
Hickory, for whatever reason, wasn't storing that in their local DB, so like the number would always be one or two.
So you hit that when you were playing and running into it.
Yeah, when I was doing more DNS stuff, and then I was like, okay, well, this is an opportunity just to like learn some Rust and try to figure out what's idiomatic. So like, if you looked at my ChatGPT history, you would see like make it more idiomatic. What is idiomatic Rust? Like, what does clean code look like? Is this the right architecture? How do we test this better? Lots of like the standard like triple check your work from a GPT perspective, especially when like I don't really know like what does clean, idiomatic Rust look like. So I ended up submitting that PR as a small one, and then just yeah, from then on, just kept trying to submit PRs and get damage. And so since then, yeah, even submitted some stuff upstream to IRO, and of course this entire desktop app is written in Rust. And so just through like the refactoring process of taking like what the MVP was that we started with to what you see now was a significant amount of Rust. I think it was like, I don't know, 3,000 lines of Rust. And but yeah, slowly learning more about it and actually coming to appreciate it a little bit more. And I don't know if I can call myself a Rustation like the rest of the Rust community, but yeah, it's been fun.
Cool. We'll take a break. Anyone have any just questions about what we're doing with desktop or tunnels or what Zach's been hacking on?
Hey guys, do you have is there any thoughts around supporting like legacy protocols like IPsec or something to support like site-to-site VPN tunnels to integrate into the experience?
Will do what my bosses tell me to do.
Who's your boss, Zach? I want to know who that is.
Yeah.
What's your thinking there, Nick? What do you just bring it forward a little bit more for us?
Oh yeah, just to let's say connect devices, enterprise devices like Cisco firewalls or stuff you can't like just start running code on top of that have some legacy
Yeah.
workflows and support and protocols built into it. Wanted to get some of the devices behind that, clients behind that don't necessarily can't run code on those devices to some cloud environment somewhere.
Yeah.
Nick, it's Zach here, but that's definitely the idea with kind of we started with the tunnels in this way because we think it's, really easy to get random things connected, new stuff. But absolutely, we want to kind of extend this to be more of a virtual meet me room. We have to have some routing capabilities there to bridge networks, but we'd like to not only take in kind of traditional network as a service stuff, layer 2, layer 3, direct connect, on ramps, et cetera, but also VPN, Tailscale, WireGuard, et cetera. So we got a lot more to add to this, but think of it as a virtual meet me room. And this is just a good way to get a lot of new apps connected in.
Yeah, I've got a lot of let's say security cameras or stuff that I would like as a pet project that I would like to bring into and have more networking features over and network control over that I can't necessarily run a client on top of. So stuff like that.
Sounds good.
I'll add, so like there's lots of things that you can do with the current, what we call HTTP proxies or HTTP tunnels. Part of what I was doing last night was like seeing how we can do like TCP over HTTP. That's of course just using the existing pattern, but like I think something like a TCP proxy that we support also makes sense as just like a standalone tunnel. You get a lot of other things on top of it. Manish, we were talking about this yesterday, but
yeah, I think IP connect is what we're looking for. The connect methods. There are multiple connect methods possible with mask on the quick tunnels, so you can do everything, any tunneling, right, over this. So Nick, that's kind of the answer to that one.
Cool, thank you.
I got like 90% of the way to get Postgres running end to end over this tunnel.
Sweet.
Yes. So we're super close.
You can do it. Cool.
Awesome.
All right, guys.
Awesome.
Well, you'll hear more about tunnels as they get more flexible and whatever. First desktop, that'll be fun. We're doing it partially. I mean, really, the inspiration for this was like some of our web team. Ronger's not on the call, but he's based out in Jakarta, and he was like, "Here is staging and Grok URL," and we're like, why is not on Datum proxy? And so this was a way for us to start doing a thing, bringing things in, wrestling with these tunnels, which we're super excited about for like probably like more cloud-like use cases. But there's like some really neat stuff happening in terms of peer-to-peer and edge and bringing stuff in from all over the place in sort of more deterministic ways. Get smarter about the client, get smarter about the path. So keep hacking on it, Zach. All right, so let's transition gears and move away from, I think we're going to move away from proxies and tunnels. But Scott, you've been hacking on a bunch of stuff underneath the cloud mainly. Yeah? I was hoping you'd share some of that. I mean, everything from ClickHouse and activity logs over to like taking the monies in. So would you kind of give us a little sense?
Okay. Yeah, so no fun game on my side, unfortunately. But
I'm sure we can make one. Yeah.
I can do a little demo. So
Activity logs or something.
Yeah, we'll do some activity logs. So a lot of my work over the past couple of months has just been getting usable activity logs in place. We really want to try to emphasize or making it easy to discover, when things break, what happened leading to them being broken, whether that's our own internal visibility, or really, giving users the ability to diagnose these issues themselves, so they can understand how infrastructure is changing, why it's changing, who's changing it, whether that's our own consistent components changing it on behalf of users for some reason, or even AI agents changing it for some reason. So I'm not a front-end developer. It's been probably 8 years since I've done front-end development, but I've got Cloud Code now. So I've been leveraging Cloud Code a lot internally, mainly to help prototyping and building UIs. That way I can try to get feedback around really the direction we're heading, or just play around with the UI, because API development's all fun and all, but it's not fun to do, API clients here and there just to try to test out functionality. So What I'm showing is actually a end-to-end environment for our new activity system running in a kind of cluster on my local computer. We'll get more into the architecture of this later. It's running ClickHouse under the hood and NATS for event streaming. And since our entire platform is built around the Kubernetes API server, we can take advantage of really two main event feeds. We've got audit logs and events. And audit logs are very technical in nature. They're very structured logs that give who did what API endpoint they were hitting, what the user agent is, IP information, what groups the user was authenticated with, response codes, full request response objects. There's a lot of detail. Fortunately, it's not really consumable for users. Like if you try to quickly scan this stuff, it really doesn't make a whole lot of sense unless you really know what you're looking for. So try to make that a bit more humanized. And so one approach we're taking here is actually introducing the concept of policies that are just registered for specific APIs or specific resources in the APIs, and then rules that determine how to convert that resource's activity into something that is actually consumable for humans. And so what this view shows right here is some activities that have been generated from audit logs that are flowing in the system. And this is all Kubernetes based today, but since we're built on top of Kubernetes, it naturally translates into Milo and Datum Cloud. I actually had ChatGPT, or no, it's Cloud Code, go through every single API resource that lives in Kubernetes and create sample policies to generate this. You can get very customized with this. You can take advantage of full request and response bodies when you generate these activities as well. So it's super powerful. But the other cool thing we added was real-time streaming. So if I do a deployment to my local environment, you'll see that as the deployment happens, the activity feed is updated in real time as events are flowing through the system. The other big benefit of this approach is we now have a very reliable event stream of activity happening across the platform that we can use to power other systems across the platform. So things like searching, workflows, or anything that needs a reliable event queue to power. And I think the other one cool thing that we can do is now show resource history over time. So if I go in here and I look at a specific resource, I can see every interaction that resource has had over time, and who did it, why I did it. We're planning on adding an event feed into this as well. So Kubernetes control plane components can emit control plane events to just give an indication of things it's doing to a resource. So if it's like restarting a pod, if it's scaling up something, if it's programming an IP address into the DNS system, if it's attaching a route to a gateway, these things can all be exposed through events and related to those resources. And so we can build not only a history of what humans are doing to this, but what control plane components are doing to this as well, and give you like full end-to-end visibility on what's happening. So now let's talk about architecture a little bit.
Cool. Just did architecture. You're going to go to architecture of that or architecture of other stuff?
Architecture of that.
Cool. But anyone can pipe up if you want to pause it.
Yeah, you got to hit me. So I mentioned this is really powered off of two primary data sources, audit logs and events. For our audit log pipeline, we are using our API servers all emit audit logs to a vector deployment that lives on the same node as the API servers. That way we can just make sure that there's minimal latency between it emitting that event and getting down to something that can actually store it durably. Vector is configured to send into NATS, and then NATS will send into Vector again, which then ends up going into ClickHouse. The benefit of this approach is we get end-to-end durability because Vector on both sides is using disk-backed buffers to store events to make sure that events are all flowing through the system and they won't be acknowledged until they actually end up in ClickHouse. Then we just use Nats really as a backlog. So that way, if components of the pipeline are down, it just buffers into the Jetstream, and then we can pick up when things come back online. Nats also lets us do a lot of different consumers. And so that's actually what's powering our real-time streaming and will eventually power streaming of other systems. So you can just tap into Nats and say, hey, I want a event stream of every single audit log that's happening across the platform. And we can tap into it. Eventually, we can expose that externally too and say, hey, you can tap into just your audit logs for your project or your organization and send them to whatever you want, whether that's workflow service or something else. On the for the policy side, we talked a little bit about that. It's really just a very simple match on a resource, and then you define audit log or audit rules that match using cell expressions. So cell is pretty popular in the Kubernetes community. It gives you a type-safe language to do expressions and filtering. And so we both use that to match rules and then also generate activity summaries. For the live streaming model, everything flows into Nats. And then when you establish a watch connection against the API server, that actually creates an ephemeral consumer in Nats that lets you stream results back to clients. The nice thing about that is clients can disconnect, reconnect, and start where they left off of. And then I think right now I have it configured to like a 30-second timeout where if a client disconnects for more than 30 seconds, they have to create a new watch stream to get changes. But they can also go back in time and say like, hey, give me everything from like this revision history forward, and they can pick up where they left off, which is pretty nice. And then
while you're riffing, can I ask the group if how long do y'all store this stuff for? Like for like security, compliance, enterprise kind of concerns. Clearly, there's like operator concerns in here, but there's also like this question, like what's any kind of standards out there for must keep detailed information about activity and events for what, a year or two, 3 months? Never. Wait, I forgot. You have to pay more for that. That's right.
Yep.
That's why we're all like, oh, don't do it.
Yeah, I think I've typically seen at least audit logs for a year.
Is it super heavy and expensive? Like what's the volume here, Scott, in terms of the cost to maintain and store this?
It can get heavy. We're trying to reduce costs here we actually have ClickHouse configured to push all audit logs to S3 for cold storage.
Yeah.
That way we only maintain 30 days of 90 days of activity or audit logs in a database somewhere that's
makes sense.
And then push everything into cold storage after that. And then I think you can even get fancier with it where you can put it into like archive storage.
Iceberg,
and make it not accessible. But
cool. Sorry to interrupt your flow, but
no worries. Good question. So for multi-tenancy, we really support 4 scopes today. So that way, platform operators, internal staff can see activity across all organizations, all projects, all users. That way, we can help troubleshoot issues as they come up and get insight into what's happening. Organizations have their own scope where you can query for an organization's activity. Right now, that is just activity specifically within the organization. It doesn't have inheritance to inherit like all project level activity within the organization. It's primarily just organization scope today. Project level activity, so you can see all activity across your project, and then one special scope for users, so that way you can see your own activity across the entire platform, across all projects. One interesting thing that we ran into in like early stages of like building out the audit log pipeline is we initially set up the ClickHouse schema to optimize for tenant-based querying, so you could do like organization queries or project queries extremely fast. It was like something like 50 milliseconds to scan several million records just to get results back, which was that was nice. Much better than we were getting with Loki. But the second you started running platform level queries or user level queries to try to get like cross tenant data, they kind of started shit in the bed. And so what we did is we used ClickHouse has this concept called projections, where you can actually use a database table and create like a materialized view into a different table and query it, have the data lay out a little differently so it's optimized for different querying patterns. And so now we have really like I think it's 3 projections: one for platform-wide activity, one for user-wide activity, and then one for tenant level scoping. We're able to use the tenant scoping to power both organization and project level querying, since we don't support inheritance today, but I need to revisit that in the future. And then think that's it I had on. That's all I had on the activity system. Any questions around that stuff? No, went through a lot.
How's it going? I mean, it seems
It's
like
good.
it's going great, but
Yeah, it's good. I think we've gotten to a good spot on getting a policy engine in place. Really, like the last piece is getting events piped in from Kubernetes. The biggest restriction around events today is they're only stored for an hour in Kubernetes. They're typically TTL'd pretty quickly, and they're also all stored in etcd, which is not ideal. And so I'm going to look at how we can actually either replace the backend storage system for events with ClickHouse and NATS, or at least just have a good pipeline to get that data out reliably and fed into another system. Because obviously, if the pipeline's down for more than an hour, we'd lose the ability to do events.
right. Cool. Well, I know you got to talk about the money next, but this feels to me like there's a few big boulders around like primitives that you just got to have to run a system at scale. Authorization, activity, kind of user data structure. Which other ones like are so important that you're like, that's got to be done right, versus like iterate, ship it, move, go. Can you just riff on that for a second?
Yes. Yeah, I mean, I think activity logs is extremely important because you need reliable eventing to power distributed systems, especially when you need to have a lot of components reacting to situations in the platform.
Yeah, distributed like in more than one place or in like 50 places. Like, what's your definition of distributed these days?
Any microservice system that is asynchronously reacting to platform behavior. Not even necessarily, it could even be within the same cluster. But yeah, we obviously have a different situation where we're acting globally.
It seems like a lot of people are too. I mean, a lot of service providers are no longer just like over here SaaS app, but like orchestrating resources kind of everywhere.
Yeah.
Right?
Yeah, you need to now have multi-regional deployments and federation across those deployments, and make sure that state is consistent in how it gets from one place to the other. Yeah, so I think the eventing foundation is critical. I think workflows is going to be another critical component where we can react to those events in a very declarative and consistent way without having to redo or rebuild that functionality across different services. I think one of the other big foundations is going to be telemetry and getting a good, reliable metrics pipeline with alerting and notifications in place. Because ultimately, if you want to bill your customers, you need to know how much they use.
How much did they use? I mean, it's a big question.
Yeah, you need to know
one would think it's simple, but like we've all spent time with NetFlow.
Yeah, and make it reliable and make sure it's accurate, and have the same consistent view on things. Because you don't want to have to keep rebuilding that pipeline over and over again and question, all right, well, Why does the invoice say one number, and why does this dashboard over here tell me a wildly different number? Like, how do I start rectifying that?
That's always a really good trust indicator right there.
Especially when there's like 10 different services in the mix that are responsible for it.
Mm-hmm. Cool. Well, I think you're going to talk about the money, so maybe that's a good segue, right?
Yep. Yeah. So the other thing I've been working on is getting a really a roadmap together for Milo. Is size on this good? Everyone see this?
Yeah. It looks great.
Okay. What I've tried to do is go through all the things that we want to build for Milo, and try to sequence dependencies based on what needs to be built to unlock the next thing. So obviously with audit logs, that unlocks a lot of ability to do things like searching across the platform, human readable activity logs, workflows, fraud and abuse scenarios. But one of the big things we want to focus on is the monies and actually getting money from customers. And so what I started going through was how do we get to the point of being able to generate an invoice, or actually taking money from that invoice, or handling situations where someone doesn't give us the money. And so what I laid out was really end to end how we get from the service catalog all the way down to invoicing. And so the it starts off with the service catalog, because that's where our service provider, Datum Cloud, would be able to configure, here are the services that we offer to customers.
This is like what we're selling, right?
Yeah, here's what you can buy. It also gives us the control of like, hey, like, what does quotas look like? How much can you consume? What's the pricing? What should the pricing of this look like? How do I manage the consumers that are actually consuming the service? Feature flagging is extremely important too, because being able to control like, okay, you purchased this product, so that means you only get access to these features or this functionality. And then entitlements of like, what have you actually purchased, and what does that give you access to, and how do we can make sure that you only get access to the things that you actually purchased. And then we get into the really fun side of things, where it's the sales enablement cycles.
I'm so glad you feel excited about this, like me.
Quoting and contracts.
I mean, commercial experience, right?
Yeah.
Sales is a good stand-in for that, but yeah, quote,
Yeah.
cash, the service delivery, all that.
Yeah, making sure there's an integrated quoting process. That way, sales teams are building quotes that are actually realistic and based off the service catalog and how the product is actually built, and not through some spreadsheets that aren't being tracked anywhere, or don't have.
You meant to say sales agents, but like in the modern way, not in the old way. I mean, really thinking about it this way is important. It's like machine to machine interactions. They're going to do all these steps at some level.
Right.
And so being able to, generate quotes, even if a human approves them, cool. Like there's needs for quotes, whether it's automatically delivered and turned into a signed contract or not, right?
Right.
Mm-hmm. Sorry to it doesn't get me all excited. I'm going to mute.
Glad I'm not the only one. And then also handling the legal side of things. And so when you accept the terms of service, or there's a change in GDPR, how do consumers actually see what they agreed to? How do they see the contracts that they signed? How do they see what they're committed to? And having a single place to reference all that information. That way it's very easy. And it's not just, hunting through someone's inbox that probably left the company a few years ago just to track that down.
Yeah, the swivel chair between systems is very real in go-to-market. It's like talk to your sales guy so he can literally go find it in Salesforce so that he can go get it check on the fulfillment process. That's like a big part of the job. Clearly, that's not a scalable or best use of time, right? Best use of value. And so stitching this together to be end-to-end, it's going to be a little opinionated, I imagine, but huge unlock for just the friction in go-to-market right now. And, clearly not in all companies, but in many. Yeah,
I definitely think it's extremely opinionated on the lens of, modern service providers and what they need. Because I don't want to build the next Salesforce that tries to solve all the problems, because I think that's the big issue people are having today is they end up in these crazy build cycles with Salesforce that, take 5 months to build something that doesn't actually work for their workflows and
Sure. Yeah.
start the process again.
Right. Yeah, I've found particularly that technical founders of new companies, first of all, are getting to go to market faster if they're fortunate, and they're getting to enterprise go to market even faster. But most of them aren't super familiar with those things you just talked about, the legal parts of it, the contract flow, moving something from, a quote to a contract to a service delivered thing is, like, especially in a cloud world, it's kind of like already been solved. Like AWS does it really well. It's complicated, but it works. And yet building that logic in that system and scalable, there's like not a lot of great tooling. There's some really good quoting tools. They're simple. You got to have a good price book, or there's good metering. You just got to know everything that happened, right? So there's some really interesting ecosystem partners to integrate with here. And I think that's important for us to call out, is that this isn't about building all those aspects. It's like being a consistent core system of record for all that stuff, so that you can use a metronome or use a orb or use a Stripe or use a whatever for the right purpose, without building your business around, say, Stripe's product catalog.
Right. Yeah. Be the control plane, but enable plugging into other providers to actually power the business.
Cool. Like fraud. Jose, you've been working a little bit on fraud, right? And that's a great example of, like, there's many things one can and needs to do themselves, but there's a lot that a lot of other companies do best in class. And there's a whole set of new challenges there that we can't even imagine that someone else hopefully is thinking about. Cool. All right. I hope this was useful. This was just really informal for us. It fit in our flow because we've been pretty busy. I think next month will be a little bit more. We're shipping Datum Desktop, which is great and fun. So that'll be out there. We're going to be removing our wait list, and we're reorganizing a bunch of our product right now to make it simpler to use, more intuitive, the relationships between things like, your edges and your tunnels and your DNS and your domains and whatnot. So hopefully that'll be more do and less talk on that side. And we'll be hopefully moving into things like talking more again about SRv6 and our kind of galactic VPC that we've been, working with, but sort of haven't been at the front of our desk for a couple months, actually. So that'll be good to have it back. Any questions or things from the crew or things you guys are seeing out there? There's a lot of cool gateways going on. I saw ngrok Gateway and Tailskill's doing something, and some interesting things happening. No? Okay. All right. Sylvia, look, it's very quiet in this room. It's just you and me and Scott.
Guys, come on. Jump in.
Get the music going. All right. Well, look, thanks for dialing in for a check-in. We'll see you next month. If there's still problems, Nick, around your calendar, you let us know. We'll find you. We'll get you hooked up. But otherwise, I hope you guys stay warm, and we'll catch you in a few weeks.